Property number 2. The property number 2 is sin inverse of minus x is equal to minus sin inverse of x, where x greater than x element of the closed interval minus 1, 1. That is the domain of sin inverse of x. Tan inverse of minus x is equal to minus tan inverse of x, where x element of the set of all real numbers. Cosec inverse of minus x is equal to minus cosec inverse of x, where x greater than or equal to 1 or x less than or equal to minus 1. These are the three set of results under the category property number 2. We can prove that. I am proving only one, the remaining you can prove. Sin inverse of minus x is equal to minus sin inverse of x, where x element of closed interval minus 1 to 1. As usual, we are assuming that sin inverse of minus x is equal to y. In the case of cosec inverse also, we have taken the same way. Sin inverse minus x is equal to y. So, what will be minus x? Minus x will be sin y. Let us bring the minus to right hand side. So, x will be minus sin y. So, but minus sin y, sin of minus y, we have checked that case, the result also. So, x is equal to sin inverse minus y. That is, but what is x? Sin inverse minus x is, So sin inverse of, bring this sin inverse to left hand side, sin inverse of x is equal to minus y. But y is sin inverse of minus x. So we can have that result, y is equal to minus sin inverse of x, that is sin inverse of minus x is equal to minus sin inverse x, a simple result. All these results are very, very important. The properties are very, very important. Now, let us check the property number 3. Inverse of minus x is equal to pi minus cos inverse of x. Sec inverse of minus x is equal to pi minus sec inverse of x in that domain. Cot inverse of minus x is equal to pi minus cot inverse of x. So, a set is having having minus of that inverse trigonometric functions. Another set is having pi minus of that inverse trigonometric function. Just connect that, you can remember easily in that domain. I am going to prove in the first result that cos inverse of minus x is equal to pi minus cos inverse of x. Here comes the proof. Let cos inverse of minus x is equal to y. So same way, bring the cos inverse to right hand side, so we will get minus x is equal to cos y. So x is equal to minus cos y. I am bringing this negative to right hand side. Now what is minus cos y? Minus cos y is cos of pi minus y, because it comes in the second cos, negative in the second quadrant. We are taking the 0 to pi case for the cos inverse. So it is cos is negative in the second quadrant. So we can assume that pi minus of y. So in the next case I am taking x is equal to cos of pi minus y. Now bring the cos to left hand side. So cos inverse of x will be pi minus y. Okay? But what is y? Y is cos inverse of minus x. So this is bringing cos inverse to right hand side and y to left hand side and applying this result. So cos inverse of minus x is equal to pi minus sin inverse of x. Next is result number, property number 4. Sin inverse x plus cos inverse of x is equal to pi by 2 in the domain minus 1, 1. Same way, tan inverse of x plus cot inverse of x is equal to pi by 2, where x element of 1. Same way, sec inverse of x plus cosec inverse of x is equal to pi by 2. Cosec inverse of x plus sec inverse of x is equal to pi by 2. When mod x is greater than or equal to 1, mod x greater than or equal to 1 means x less than or equal to minus 1 or x greater than or equal to 1. Here also I am going to prove the first case. Sin inverse x plus cos inverse x is equal to pi by 2. I am going to prove it. So, I am assuming sin inverse x is equal to y. So x is equal to sin y. Sin y can be written as cos of pi by 2 minus y, the complementary angle property of trigonometric functions. So x will be cos of pi by 2 minus y. Let us bring the cos to left hand side. So cos inverse of x is equal to pi by 2 minus y. Am I correct? Let us then bring this minus y to left hand side. So we are getting y plus cos inverse of x is equal to pi by 2. But what is y? Y is sin inverse of x. So we have proved that sin inverse of x plus cos inverse of x is equal to pi by 2. Now, next is result is another set of important results. Tan inverse of x plus tan inverse of y is equal to x plus y divided by 1 minus xy when xy is less than 1. Xy less than 1 can be x positive, y positive and xy is less than 1. It can be x negative, y negative and the product of x and y may be less than. Same way, one is positive, one is negative also, we will get the same condition. All these, whatever it may be. You just remember that xy should be less than 1, then only this result will hold. Now in our textbook we have to discuss this only. In some when we are doing some particular questions, some additional results is required, that I will explain in the next session. Same way, next is tan inverse x minus tan inverse y is equal to x minus y divided by 1 plus xy, where xy is greater than minus 2. The third result is 2 tan inverse x is equal to tan inverse of 2x divided by 1 minus x square, when modulus of x less than 1. Modulus of x less than 1 means that it lies in the open interval minus 1 plus 1. That is minus 1 less than x less than 1. We shall prove the first case. Proof of tan inverse x plus tan inverse y is equal to x plus y divided by 1 minus xy, where xy is less than 1. Let us take tan inverse x is equal to a and tan inverse y is equal to b. Then definitely x will be tan a and y will be tan b. Now let us use the trigonometric result what we have studied in class 11. Tan of a plus b. Tan of a plus b is tan a plus tan b divided by 1 minus tan a tan b. But tan a is x and tan b is y. So instead of this we can write x plus y divided by 1 minus x into y. That is tan of a plus b is equal to x plus y divided by 1 minus xy. Let us bring the tan to right hand side. So you will get a plus b is equal to tan inverse of x plus y divided by 1 minus xy. But what is a? A is tan inverse of x. What is b? B is tan inverse of y. So we have proved the result. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus xy. Dear children, for the next result, it is very simple. What to do here now? Let us take this result. Take this result. Now replace y by minus y. Instead of y, just replace it by minus y. So we will get this I am writing here. We will get tan inverse of x plus tan inverse of minus y is equal to tan inverse x, y is replaced, so x minus y by 1 minus x into y is x into minus y, so it becomes 1 plus x. But what is tan inverse of minus y? Tan inverse of minus y is minus tan y. So this is tan inverse. Tan inverse of minus y is minus tan inverse of y. So this will be equal to tan inverse of x minus tan inverse of y equal to tan inverse inverse x plus y by 1 minus x y. That's all. We got the second proof. Now if you want to prove the third result, that is 2 tan inverse of x is equal to tan inverse 2x by 1 minus x square. It's very simple. In this result, replace y by x. Instead of y, you just replace x. So you will get a tan inverse of x plus tan inverse of x. So 2 tan inverse of x equal to tan inverse x plus x is 2x by 1 minus x into x is 1 minus x square. So proof is over. So that is a simple proof. Now let us discuss property number 6. 2 tan inverse of x is equal to sin inverse 2x by 1 plus x square, where mod x is less than or equal to 1. Means x lies in the closed interval minus 1, 1. So this is an important result. 2 tan inverse is equal to sin inverse 2x by 1 plus x square. Same way, 2 tan inverse x is equal to cos inverse 1 minus x square by 1 plus x square, where x is greater than or equal to 0. X should be positive in this case. And the third one is 2 tan inverse x equal to tan inverse 2x by 1 minus x square, where mod x less than 1. This already we have proved. This third one we have proved it. Now these are the 3 set of important results. We shall prove the first one. Let a tan inverse of x is equal to y. I am taking tan inverse of x is equal to y. So what about x? X is equal to tan y. Now, sin inverse 2x by 1 plus x square equal to sin inverse, instead of x I can substitute tan y. So it is sin inverse 2 tan y by 1 plus tan square y. Now in class 11 we have studied that 2 tan y by 1 plus tan square y is nothing but sin 2y. So this is sin inverse 2x by 1 plus x square equal to sin inverse sin 2y. This is the result that we have studied in class 11. The result what we have studied in class 11 is sin 2y is equal to 2 tan y divided by 1 plus tan square y. There we have written as x. It's nothing. So it is the sin 2y only. Now sin inverse of sin 2y is 2y. So sin inverse of 2x by 1 plus x square, here we will get 2y. But y is what? Y is tan inverse x. So the result is sin inverse 2x by 1 plus x square is equal to 2 tan inverse of x. Dear children, these are the main results of inverse trigonometric functions, the properties of inverse trigonometric functions. Try to remember all these results, properties, because we have to apply these properties for solving different kinds of questions. Okay?